Going to be the notes for section 1.7, distance and midpoints. The objectives are I will be able to find the distance between points, and I will be able to find the midpoint of a segment. So let's get started with the distance on a coordinate plane. We have a couple things here. We have the Pythagorean theorem, and we also have the distance formula. The distance formula is a special application of the Pythagorean theorem. If we want to find the length of segment AB, which goes from A to B, let's start with the Pythagorean theorem. This is a right triangle, so all we really have to do is count the sides. So 1, 2, 3, 4. So this side here is 4, and the other side is 1, 2, 3. So that means A would be 3, B would be 4, and we need to solve for C. So 3 squared plus 4 squared is equal to x squared. If I want to find out what 3 squared plus 4 squared is, I can just put that in the calculator. And it's 25. So 25 would be equal to x squared, and I would just take the square root of each side, and on your calculator you hit second, and the square button gets you square root 25. So x is going to be equal to 5, so the distance is 5. If you need to copy this down, please do it now or pause the video, because I'm going to use the distance formula now. The distance formula has us use x2, x1, y2, and y1. So whenever I have these 2 points, you'll see that it'll end up with the same answer. I can call this x1, y1. I can call B point 1, and A would be x2, y2. So whenever I substitute that in, I'm going to get negative 2 minus 1 squared. That's x2 and x1 plus y2 negative 1 minus 3 squared. Again, that's y2 and y1. So one option that I have is I can just put this whole thing in my calculator. So parentheses negative 2 minus 1 squared plus negative 1 minus 3 squared. And I get the same exact answer of 5. Those are the 2 ways to do this. The nice thing about the Pythagorean theorem is you should already have this formula memorized. We're going to use it a lot later on in the year too. The distance formula, a lot more numbers to remember, but you can get it done with the calculator pretty easily. So if I look at the next example, these points aren't plotted, so let's plot them. Negative 3, 2, so remember that's the x, 1, 2, 3, and then the y, 1, 2. So this is point C, and D is 4, so we move to the right 4 and down 1. I need to find the length of this right here, so I can make a right triangle and figure out the Pythagorean theorem. So I go down 3, and to the right, 1, 2, 3, 4, 5, 6, 7. Okay, so if I need to solve this, I can just do 3 squared plus 7 squared is equal to x squared. Again, I'll use my calculator. 3 squared plus 7 squared. I get 58. And I'll take the square root of both sides. And I get about 7.6. It goes on forever, so x is about equal to 7.6. If I want to solve it using the distance formula, it's just going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, this is x1, y1, x2, y2. And all I'm going to do is substitute those numbers in. So x2 is 4 minus negative 3 squared plus negative 1 minus 2 squared. I'm just going to put it in my calculator exactly like that. So the square root of 4 minus negative 3 squared plus negative 1 minus 2 squared. And sure enough, I get the same exact answer. I get about 7.6. So what I would like you to do on your own is number 2. So to get you started, I'll plot the points here, 7, 4, and negative 1, negative 4. So do this on your own. Whenever I go around and check the notes, I'm going to make sure that you got the right answer and you showed the work. You can do it either method. So use either method. Let's go on to the back page. We have a couple definitions here. First off, we have midpoint of a segment. That is the point halfway between two endpoints of a segment. So we're going to use some things that we learned in section 1.3. If I have points here, so there's not really points, so we have points P, Q, and R. If Q is the midpoint of PR, then we're going to have two congruent segments. Remember that mark means congruent. So this means congruent. And remember, the symbol for congruent was the equal sign with the tilde on top. Congruent just meant equal. The congruent sign even looks like equal. So I'm going to have segment PQ is congruent to segment QR. So all midpoint does is cut segments in half. A related note is the midpoint of a number line. So we have a number line up in our room, and we have a number line right here. So the definition here is if the coordinates, so remember the coordinates are numbers. So the coordinates here are negative 10, negative 8, negative 6, so on and so forth, the numbers. The coordinates of the endpoints of a line segment are A and B. So if the coordinates of the endpoints of a line segment are A and B, then the coordinate of the midpoint, and we're given this equation right here. So midpoint is very simple. We just add up the two coordinates and divide by 2. So for example 2 here, C is negative 4 and E is 2. So all we do is negative 4 plus 2, and we add it over 2. This is really simple in our calculators. If you get alpha y equals enter, we get a nice fraction bar. Negative 4 plus 2 divided by 2. You don't need to worry about order of operations here. And we get the correct answer of negative 1. A lot of you can do this in your head also. So DG, we get 0 and 8. 0 plus 8 divided by 2. Again, let me show you that calculator trick. Alpha y equals enter. 0 plus 8 divided by 2. It's 4. Again, something you should be able to do in your head. The last one is negative 11 and 8. This time we don't even have to look at our number line. Negative 11 plus 8 over 2. The nice thing about this calculator trick is that it'll normally leave your numbers in fraction form, so you don't need to even hit math enter. Correct answer will be negative 3 over 2. So again, we just use the midpoint formula for those 3 problems. If I want to find the coordinate, a midpoint of a coordinate plane, all I do is use that same midpoint formula we just learned twice. I take the average of the x's and the average of the y's. So all I'm going to do is x1, x2, that's going to be 0 plus 12. I'm going to divide it by 2. And the other point I'm going to have, the other coordinate is y1 and y2. So I'm going to have 0 plus 8 over 2. Because I'm such a fan of the trick on the calculator, I'm going to do this on again. Again, alpha, y equals enter, 0 plus 12 divided by 2. You get 6, and alpha, y equals enter, 0 plus 8. So our midpoint will be 6, 4. That's what happens whenever we put those in the calculator or just do this simple addition. Let's do the other one together also. So we have x1 and x2 there. So it's going to be negative 12 plus 6 over 2. And there's also y1 and y2. So it's 8 plus 12 over 2. Again, using the calculator, alpha, y equals enter, negative 12 plus 6 over 2, we get negative 3. Alpha, y equals enter, 8 plus 12 over 2. So our final answer is going to be negative 3, positive 10. That's how we calculate the midpoints. So the last several problems here are probably the trickiest things that we'll do, or the next two I should say, finding the other endpoint. So for this example, the best thing to do when you need to find the other endpoint is to graph it. So I just make a coordinate graph right here. I'm told that t is the midpoint of SR. So t is negative 1, positive 1. There's t. And R is 2, 4. I have to find S. So what I'm going to know here, so this graph isn't perfect because I just drew the coordinate plane, but S is going to fall somewhere on this line. Because I'm going halfway, I'm going down 3 and to the right 4. That's how I go halfway. So how am I going to go halfway again? I'm going to go down 3 and to the right 4. Sorry, left 4. Let's see how close I made this. 1, 2, 3. 1, 2, 3, 4. So that's my point right there. That's point S. And as you can see, I have two congruent segments. ST is congruent to TR. So what is this point? Negative 1, 2, 3, 4, 5, negative 2. So it's going to be negative 5, negative 2. That's the easiest way to do this. So again, I just go down 3 and to the left 4. Let's do another example, example 5. Or sorry, it's actually try 6 on your paper. You may need to use another sheet of paper because this takes up a lot of space. So again, we're given K is 2, 1. That's the midpoint. So there's K. And so that's the midpoint. And W is 3, negative 2. So there's W. So since K is the midpoint, I'm going to start at W and go through K. So how far did I go? I went to the left 1 and then up 3. So I'm going to do the same thing. I'm going to go to the left 1 and up 3. There's my point. This should be, doesn't even give us a letter. Oh yes, it does. It gives us J. So J is just going to be, so again, I went to the left 1 and up 3. J is just 1, 4. It's really simple whenever you make the graph. So right here, we have to use the figures to solve the following problems. We have to find PR if Q is the midpoint. So since this is midpoint, remember, it's broken up into 2 congruent segments. We had practice on this already. So what I can do with the segment addition postulate is 6, sorry, there's no x there, is there? All I'm doing is copying down what the other one is. So it's 6 minus 3x. Sorry about that little mistake. So 6 minus 3x plus 6 minus 3x is equal to 14x plus 2. I combine like terms. I have negative 6x, and I have 6 plus 6, that's plus 12, is equal to 14x plus 2. I'm going to add 6x to each side because that's the opposite or inverse operation of a negative 6x. So I get 20x plus 2 is equal to 12. When I subtract 2, I'm going to get 10 is equal to 20x. And I'm going to divide by 20. X is 1/2. So I'm asked to find PR. So PR is equal to 14x plus 2. So I'm going to show you another trick you may be familiar with on the calculator. It's called the storage function. If I just do 1/2 and I use this button above on called stow and I hit X, anytime I hit X it's going to come up as 0.5. I need to store it first. So all I need to do now is type in 14x plus 2. And I get my answer of 9. So PR is equal to 9. So we can try number 7. I'll just get you started there. Again, we know that these 2 segments are congruent because B is the midpoint. So 4x minus 5 is equal to 11 plus 2x. We're done with the problem whenever we find the measure of BC. So do this on your own. Again, please feel free to ask me any questions at any time. Have a great day.